This lesson is Add Exception Handling to Web API Calls. The objectives for this lesson are to take a look at the global exception handling built into ASP.NET, talk about profiles in Visual Studio so you can see how exception handling works differently in development versus production. We're going to set up some custom exception handling, talk about status code handling, and exception logging. So ASP.NET has built-in global exception handling. So when you don't handle an exception, ASP.NET is actually going to return a 500 status code, an exception message, and a stack trace. Now, you can, and really you should, override what is returned. You don't want to return all of that information because that might have too much information about your server, and you never want that to get out to whoever's calling your API. So let's go ahead and do our first demo here, which is we're going to create an exception and we're going to view what ASP.NET gives you back. Open up the product router class and scroll down to where you're getting the list of all of the products. And let's add a little bit of code in here that will intentionally cause an exception. So we're going to do a throw new application exception error. Now let's go ahead and run this. Let's click on the get, try it out, and execute. And what's going to happen with Visual Studio, it's going to pop up where the error is. Of course, we don't care. We're trying to test our error handling. So go ahead and click on continue. And now we're going to see what happens down here. Look at our response. You can see the code is a 500. The error is internal server error. And then you see in the response body, system application exception error. There's that text that we put in, and then like I said, we're going to get that stack trace. But then look at all this. It gives you all the headers and everything else about the error. And again, this isn't something you really should be returning back to the user, and we're going to learn how to change this now. Now again, if you're reading articles out there or Microsoft's documentation, they say that the exception handling goes right into Program.cs. But of course, what we're going to do is we're going to create our own error router class. And from there, we'll extend and override the built-in exception handling. Again, this provides one place that we can go to look for all of our exception handling, and it keeps our Program.cs much cleaner. So let's create our exception router. Right mouse click on the router classes folder and add a class called error router. And what we're going to do inside of here is we're still going to put it under the same namespace, the router classes namespace. We're going to create our public class error router, and we're going to inherit from our router base. Then we override our add routes method, and we do an app.map. Now notice we're using app.map, not map get. Okay, so you use, when you're doing exception handling or any sort of middleware like this, you're going to use the map method. And then we give it the path, which is production error. And to the method, we're going to pass the HTTP context. So we want to be able to get at the context of where we're at right now, because that can give us some additional information that we'll use. And then as you see, we're going to take that context and we're going to pass it down to our production error handler, which is this method right here. So we pass in the HTTP context. We're going to set up our message that we're going to return, which by default is going to be just simply unknown exception. But what we're going to try to do is grab some of the features of our exception handler. And what that does is it gives us the error object from which we can grab a message along with other properties as well. And then the return value to line 27 is going to be results.problem. Results.problem will build a message for us, and we'll see what this looks like here in just a second. All right, let's go ahead and register this. So obviously we're going to go over here to where we're adding our router classes as a service. And we'll add our error router, so then that happens automatically, right, as down here where we loop through and invoke our services. But there is one more thing we need to do. When we're trying to turn on exception handling and override Microsoft, we need to add another line of code here. Right up here, we're going to do enable exception handling middleware. And what we're going to do is app.useExceptionHandler. And then look at that. We're mapping it to that /production error that I created there in the app.map. All right, let's go ahead and try this out. We'll click on our get here that causes the exception. We're going to let it continue. And then we go down here and we check our response, and look at that. So now we got the 500 error again. But look at the response body. Now this is the results.problem. What this does is create something that says the type, it says the title, an error occurred while processing your request, the status is 500, and the detail is simply that message that we had, right? Error. Because remember, we grabbed that from the HTTP context. So this is an example of setting up your own exception handling so that you're not giving too much information to the caller of your API. The error that I just showed you is great for production, going back to the caller, but when we're in development, we might want to get a little more information. So let's set up both the development and the production exception handling routes. So where we previously added this use exception handler, we're going to override all of this here. And now we're going to do one more thing. We're going to do an if app.environment.isDevelopment. Then let's do app.useExceptionHandler / development error. Else we'll do our production error that we just saw. So that means that we need, inside of our error router, we need one more of these methods here, and we're going to need another mapping. So let's add in a protected virtual development error handler. Again, we're going to pass in the HTTP context. We're going to try to get some information about the exception. And then if that features is not equal to null, we'll get the message, we can get the source, and we can get the stack trace. So basically, we're kind of building what Microsoft had given us as part of the global built-in exception handling. Except this time, we're just kind of building it ourselves. And this way, we have development errors and production errors. So then all we have to do is add a new app.map up here. You can put it either before or after, it doesn't matter. But you just make sure that that route there matches what we had in the program.cs. Let's run this. Let's click on the one that gives us the error and we'll continue. And now we're back to kind of what we had before, right? Where we get the full stack trace, the message, the source, all of that. But now it's wrapped within that problem JSON object. So how would we test out both the development and the production? Well, we do that by setting up a couple of different profiles so that app.environment.isDevelopment flag is set to either true or false. So let's see how to set up these different profiles and test out our exception handling. Open up your properties folder and go into the launch settings.json. And if you look down here underneath profiles, you'll see an AdventureWorks API. Let's go ahead and copy this profile and paste it back in, and then change this to production, and also change this to production as well. By doing this, it sets up that environment variable so that that flag is development will be set now to false because we're going to now be in production mode. Let's save this. Once you've saved this, you can now see up here a drop-down, and one of the options is now that AdventureWorks API production. If we run this, this means that isDevelopment flag is now going to be false, so it's now going to use our other error handler. Now, when you're doing this, you can see here it's telling us that Swagger can't be found. That's because Swagger doesn't run in production mode. So we need to type in our route there directly on the URL. We'll go ahead and continue. And now you can see the error that we get here. That's that problem error, and that's the one from our production error profile. Let's take a look at handling a 404 status code, which will probably be the most common one that you'll want to send back a special message to your callers. Open up your error router class, and let's add a new method down here. And this one is a protected virtual iResult called status code. And what we're going to pass into this is the code itself, like a 404, and the HTTP context. We're going to build up a string message here. We're going to use that context.features that we saw before, but this one's using the iStatusCode reexecute feature. The reason why is this gives us a little bit more information. It'll allow us to get at the original path that was being requested, and that's what caused the 404. Now, I've thought ahead a little bit here, and on lines 30 through 36, you can see I have implemented a switch because I'm going to just handle a 404 now, but maybe in the future, I might want to handle some other status codes. So all I'm going to do in this one is I'm going to put out API route was not found, and that will be the return from our results.problem. All we need to do now is add a new app.map up here. So we'll go ahead and add that in here. So app.map, status code /code::int. Then we pass that code and the context down to our status code method. Go back to the program.cs, and then immediately after the if statement where you're doing the app.useExceptionHandler, we add in app.use status code pages with reexecute, passing in the path again, the / status code / and then our replaceable parameter. That's the one that will be fed by ASP.NET, and that's the actual status code. So if we go ahead and run this right now, we're still in the production mode, so it's trying to find Swagger, it doesn't find it, but now you can see up here we're getting back the problem detail, and look at the very end here, API route was not found, and it actually gives us the path that we were trying to get to. In our last lesson, we learned about logging. Well, let's now extend that logging so we're logging exception and informational messages into different files. So we do all of that using the Serilog package that we installed. In the program.cs, locate the area where we were builder.host use Serilog. Let's change this name here. We'll call it info log instead of just log. And then we're going to add a little bit more code on here, where as you can see, what I'm doing now is I'm doing also a log.write_to_file, logs error log -.text, and then the rolling interval is still the day. But what I'm going to do now is I'm going to add on this restricted to minimum level, and the log event.level is error. Now, what I probably want to do is do the same type of thing for the informational one as well. So what we're going to do is add on a comma here for the other write to file, and we'll add on a restricted to minimum level log event level.information. So remember our log levels, right? Trace, debug, information, warning, error, critical, all of those. Well, now anything from information and above is going to go into the info log, and everything only from error or above will go into the error log text file. Let's go ahead and switch this back to our normal development mode, and let's try this out. So we'll open this guy and we'll execute, let this continue. All right, and now what we're going to do is let's go back and let's take a look at our logs. And now you'll see I've got the two different log files here. This one is left over from before. This is now our new one that now is being written. Now we're still getting the error inside of here because remember there's only a restricted minimum level. There's not like minimum to maximum on this. So we're still going to get all the information and error messages in the info log, but we have one log file now that just tracks the exceptions. And that's kind of nice. Now, obviously, what we've been covering are things that are for the unhandled exceptions, things that you really weren't expecting to happen. But if you know that something could happen, you're going to want to wrap that code into a try-catch block. So let's go ahead and do that and then look at logging exceptions in the catch block. Open up the product router and let's add a new private read-only field that is of the type iLogger product router _logger will be the field name. And then what we're going to want to do is change the constructor here. Now look at this. Visual Studio is so smart. It knows that I need to initialize that _logger so it automatically gives me a hint here. And if I hit tab, it will automatically add that code for me. Isn't that nice? The other thing we want to do down here is when I am trying to go after all of those, I also want to say that this could now produce a 500 error as well, right? Because we're going to now actually generate that. So let's go down to the get rid of all of this and let's replace it with this. So what I'm doing now is I've wrapped up the code where we're normally going to go out to the repo and get all of those products. And right now it's hard coded. We're not going to get any errors. But what if we were going to a database and the table isn't there or there's some sort of other error that happens? That's what we're going to simulate now by right inside of this try block. We're going to throw a new application exception, which means it's going to then come down in here to the catch block. I'm going to build up a message. And what I like about this is now you can actually put in where the error actually came from, right? So I can actually say error in product router.get. I can add in the exception message, the exception source. I could grab the stack trace if I want. And then I can call that logger myself and do _logger.log error, passing in the exception, passing in my own custom message, and that's it. It'll now log all of that information, and then I can return a results.problem that says error in product API, please contact the system administrator. So what's nice about this is I'm logging to my error log so I can look at it as the developer, but the person calling my API that got the error, he's only going to get the generic message, error in the product API, please contact the system administrator. I think this is a much better approach. You should be, striving to always put try catches in wherever a problem could occur. Let's go ahead and run this. And we'll click on this guy. And now there is what goes out to the user. But if we then go back and we take a look in our logs, in the error log, we should see our information, which tells us, hey, we've got an error. It's at the routerclasses.productrouter.get. And then we've got the whole information here about where it happened. And that's great for us as developers, but there is no reason your caller needs to see this level of detail. In this lesson, we learned that we are in control of the exceptions in our web API application. We don't have to rely on the built-in global exception handling. We can add routes for specific status exceptions, and we can log exceptions to a separate file. So we have great control over the exception handling. Coming up next, modify the router base class to reduce duplicate code.